Hello everyone, welcome to the Macronix webinar. I'm the host Ashley. We are here with several Macronix managers to discuss the current flash market, how they are weathering the storm in the midst of geopolitical tensions and the COVID-19 pandemic, and where they are seeing growth in their business. We will also be talking about what the key product trends they are seeing. Let's hear what they have to say. Let's introduce our managers first. The first one is Martin. Hello, Martin.
Hi, Ashley. Hi, everyone.
Hello, Ashley. It's a pleasure to meet you.
The next one is Anthony. Hello, Anthony.
Hi, Ashley. It's nice to meet you.
The last one is Jane. Hello, Jane.
Hi, how you doing, Ashley?
The first questions we are going to ask Anthony. The world's economy is impacted now more than ever by a lot of pressures. And we're curious about that. How has Macronix business weathered those challenges? Any surprises?
Yeah, Ashley, thank you. It's a pleasure to meet you, and thanks for spending time with us. So first of all, with the pandemic, Macronix would like to send our heartfelt sympathy out to those who've been impacted by the pandemic. While there has been some impact to Macronix, like the downturn of the automotive industry, the consumer goods sectors, we have been working really hard for the past 5 years to diversify our business. So though we can't predict such global events like the pandemic, the diversification has actually allowed us to quickly shift our business to meet market conditions. Okay, so overall, Macronix has weathered pretty well in 2020. There are a few growth sectors that were driven by the pandemic: the gaming industry, networking, computing, and home medical electronics, right? The computing market's quite broad, and we've seen strong demand from data centers to personal computing, and it's really supporting the remote working and learning that we're seeing around the world. And in addition, we see the 5G infrastructure equipment and AI driving growth now and beyond 2020. So for Macronix, the flash market's been relatively stable for us.
Thank you, Anthony. The following questions we are going to ask Martin.
Hi.
Hello. What's the current embedded market outlook for flash memory, and what's the current market share between different memory types and the different interface types?
Okay. In general, the embedded market for flash memory size is close to 4.5 to 5 billion US dollar. If we are looking down for the memory types, the NOR flash is 2 or 2.5 billion. SLC NAND is around 0.7 to 0.8 billion. And managed NAND, for example, like the EMC or UFS, is around 1.8 billion. And look at it from the standpoint of the memory interface, it's around 80% of the NOR flash sold today is serial SPI NOR. And on the other hand, the SLC NAND is about 80% now is parallel NAND.
Thanks, Martin. The next questions we're going to ask Anthony. What market do you serve, and what does your market distribution in terms of sales look like? And where are you seeing the growth, and why is it?
Yeah, actually, the short answer really is we sell into all markets. And if you look in 2019, we shipped over 1.8 billion units. As I stated earlier, we are pretty well diversified across all market segments, and we have seen increasing demand for NOR and NAND flash, really from all these market segments: automotive, industrial, medical, communication, computing, and consumer electronics. So we continue to benefit from certain stronger market trends like the growth of connected devices, right? Then they're driving IoT and industrial IoT, all right? These connected devices require more and more NOR and NAND in their design. Where we continue to lead is really our high quality and broad range of products. A couple of good examples where we play really well in is 5G market. The base station needs higher density NOR and NAND. And the range really is pretty broad: 128 megabits of NOR up to 8 gigabits of SLC NAND. ADAS and infotainment system in automotive are also driving forces. These applications require higher density NOR and NAND devices. Again, 128 megabit as high as 2 gigabit. So both really require very stringent, high quality products as well as suppliers. So we expect the trend of increasing density requirements to continue in the coming years. Thank you.
The next questions we're going to ask Jane. We see that there are transitions taking place in terms of how flash memory is used. And we're curious about that. What market trends and the technology development are driving these transitions?
I think the biggest trend that we see is in the growth and the demand for memory density. You know, applications are becoming more feature rich. They're requiring larger operating systems. And, you know, especially for high-end consumer or automotive, infotainment systems in automotive as well. These systems are just getting a lot more complex and requiring upwards to 1 to 2 gig and even higher than that. And so that was probably the largest trend that we see. I'd say also the growth of IoT applications. So any device that senses, processes what it senses, and then sends it to the cloud, those types of devices require NOR flash typically. And so we see a lot of growth in that area. And then lastly, in interface speed growth. So we started off, you know, way back with single mode SPI, and now we're at octal. And so customers increasingly demand a higher performance. And so, for example, with octal, we're seeing, you know, demand for like in automotive, for example, we see demand for instant on capability and XIP. So those are probably the 3 biggest trends that we see.
Thanks, Jane. Following, we are going to ask Anthony. Depending on the applications, there are compelling reasons to use NOR or NAND flash. But we're curious about that. In what applications are designers choosing NOR, and when are they choosing NAND?
Actually, that's a good question. It's a difficult question sometimes, even for the system designers. But if you look at the trends in general, software systems continue to grow, requiring higher memory densities. The increased adoption and more complex OSs like Linux and Android is really a major factor. As 32-bit MCUs and even multi-core MPUs become more affordable, they are finding their way into more applications. So Linux and Android-based OSs are pretty well established, and a lot of the chipsets, or actually all the chipsets, they support both OSs, right? So when combined with applications that continue to evolve with richer user interfaces, connectivity requirements, and more features, software images have and will grow, requiring higher density flash memory, right? There are inherent advantages to NOR, of course, compared to NAND, but depending on the application, price starts to become an important factor, pushing designers to SoC, NAND flash, when requiring really 1 gigabit and higher densities. So for example, we see this higher end consumer devices like smart TVs, set-top box, and home gateways. In automotive, there's higher demand for more rich infotainment and cluster systems. 5G infrastructure, the evolving protocols are more complex, requiring more software to support it. So in general, we see demand for NOR at 512 megabit and lower densities, but at 1 gigabit and higher densities, NAND is definitely more cost effective. Thank you.
Thank you, Anthony. The following questions we are going to ask Jane. We see the trend where NAND is being adopted and leveraged for storing code and the data. What applications are adopting this dual-use scenario? And in addition to ECC, how is NAND managed to increase quality and extend the life of the device?
So this is a very useful feature for NAND flash, given its cost effectiveness, because if the SoC is designed to detect and boot from NAND flash, once that's achieved and the system completes the boot process, you know, due to the NAND's, you know, increased memory density, then you can move to a data storage type of mode. And in that situation, you have software that can really increase the memory density or the data retention of the device. So for example, it can do wear leveling, bad block management, self-refresh, and those sort of things. And if you combine that with ECC, which is a hardware function, you can start to achieve data retention and the lifetime a NAND device comparable to NOR flash. And so that's very important because when you're doing data storage, the PE cycles, the program and array cycles are much greater. And so that kind of NAND management is required. And so where we're starting to see NAND being adopted is in sort of applications like networking, like AP routers, XPONs, or enterprise routers. And then also, like Anthony said, in higher end consumer devices like smart TVs, OTT or over-the-top products, or even set-top boxes. And so, anytime you have an application that has a menu or graphics, typically you're going to find a larger operating system. It's going to require, a higher density device.
Thanks, Jane. The next questions we're going to ask Martin. How has the SLC NAND evolved from its beginning, and what does the trajectory look like for SLC NAND using embedded systems?
Okay. I think that I can have the two kind of the evolution trend for this question. The first is the market evolution. In the beginning, SLC NAND was targeting for consumer market, and then they moved to networking applications. For example, like a CPE devices, AP routers, and XPON, and enterprise routers. And now it's getting more popular in automotive and medical applications. Second, if we look at about the product evolution, in the past decades, the parallel interface was the main choice in SoC NAND. However, now we are seeing some shifts to serial NAND. And the SoC vendor are starting to adopt the ECC engine as well. And if we're looking for the future trend, the host manager ECC will be targeting applications that are more quality demanding requirements. For example, automotive, medical, networking, communication infrastructure, and for those SoC vendors, they want to serve this kind of the high quality demanding application to manage all over the system performance and efficiency.
Next, we're going to ask Jane. Let's talk about ECC for a moment. Why is ECC needed, and why is it particularly needed in NAND flash memory? There seems to be quite a bit of debate on where ECC is managing in the system. What are the trends on the management of ECC, and where does it stand now?
Well, like we talked about earlier, ECC, or error correction code, it's used to control data corruption, and it's commonly used in memory systems to detect and correct bit errors. The error correction code is stored in each page in NAND, and it's stored in a spare area. And so it's pretty effective to combat bit errors, but it takes time to calculate, check, and repair those bit errors. And this affects read performance and the cost of supporting the ECC circuitry. So historically, SoC vendors have supported ECC for parallel NAND devices. But now, memory vendors like Macronix now offer some NAND ECC-free products that handle ECC burden. So the market has a mix of parallel and serial SPI NAND, with ECC supported by the host SoC called host managed ECC, or ECC-free, where the NAND device manages ECC. And so parallel NAND, it still really encompasses about 70% of the market. But that is declining with the adoption of serial NAND.
Thanks, Jane. Next, we are going to ask Martin. Most systems now that have NAND flash design in use parallel NAND, which has the host MCU manage the ECC function. But why is it that some serial NAND devices are handling the ECC management? What is the result of this?
Okay, this is a very interesting question. The reason why is when memory vendor came out with this idea, due to the market feedback, particularly come from the cost-sensitive customer or applications. But in the beginning, they have a different kind of the products without standard specification. So the SoC vendor did not have the ECC engine to support. But long term, we believe the SoC vendor ecosystem will pick up the ECC support. So SPI name with host managed ECC will be the for those quality demanding applications such as automotive, medical, communication infrastructure, and so forth.
Thanks, Martin. The last questions we are going to ask Jane. Okay, so host managed ECC is already established and has been around for years. What are the cost, performance, and the ease of use benefits continue this trend?
Well, I'm glad you asked that question because really it's a good transition into the presentation that we have. And in that presentation, we'd like to introduce you to Salman Rashid. He's our Senior Marketing Director in the US, and he's going to do a really good job of answering those questions in that presentation. And we think that you're going to find it quite interesting. It's short, but we think it will show why we think host managed ECC is a trend that will continue. And then, while you're listening to the presentation, please feel free to ask any questions. We'll have staff online to answer those questions. Thank you.
I would like to thank all of you for this insightful conversation. Thank everyone.
Bye.
Thank you. Thank you,
Bye.
Ashley. Thanks, everyone. Goodbye.
Thank you.
This concludes this event. Thank everyone for joining. And if you have follow-on questions, please contact your nearest Macronix sales team or visit our website at www.macronix.com. Besides, if you could take time to fill out our online questionnaire, that will really help us out. Thank you.